Okay, so now for this lecture, you're gonna want to have read chapter 7 of the Silverman book. Okay, and we're gonna talk about drug resistance and drug synergism. So these are two things that come up a fair bit and have actually been in the news lately in terms of cures for COVID. Okay, so first of all, resistance. So this is when a formerly effective drug dose is no longer effective. So one of these things, when we're talking about drug resistance, we're talking about a lot of times antibiotic resistance. And so this is what happens when when bacteria naturally mutate, and some mutation is generated that happens to be resistant to the drug. And when that mutation is formed, it's going to survive, and that's what's going to become the dominant bacterial species. So this is always going to happen. So this is different than tolerance. So this is when you need a higher dose of the drug over time. This is tolerance, your body adapting. We're talking about drug resistance. We're typically talking about bacteria. Okay, so the mechanisms of drug resistance are an altered target enzyme, an overproduction of the target enzyme. We can have a different substrate. Again, this is kind of all the same thing. What it can also do is it can produce drug destroying mechanisms. It can basically figure out a way to not activate the drug. And when I say figure out, all of this is really due to natural selection of a certain clone of bacteria, basically a certain gene of bacteria that naturally happened as the bacteria naturally mutated as everything is naturally mutating at a kind of a low rate. And so randomly something popped up that has this resistance. So an example of this is of an altered target enzyme or receptor, is that you mutate an amino acid residue, and the drug binds poorly now to its receptor. And so these are examples of these. This is now talking about viruses, and so there's a couple of antiretrovirals. So these are anti-HIV drugs, and the HIV virus can become resistant to some of these antiretroviral drugs by mutating amino acids in its reverse transcriptase. So the way that the genome replicates, basically, it needs to move in between DNA and RNA, the HIV genome, and it forms the way that that's all happening. These drugs interrupt that enzyme that's catalyzing that transition, that's catalyzing that polymerization reaction, called reverse transcriptase, and these drugs interfere with it. And so what the virus is then able to do is mutate that those key amino acids that interact with the drug into amino acids that no longer interact with the drug. Okay, and so another example of this is vancomycin resistance.